What's up, everybody? My name's Russ. rwgresearch.com is my website. It has been a long week. I have constructed something and I'm going to show it to you. This is the first video in the series of my filament extruder. Bear with me on the first few moments of this video. It's going to get interesting. So, this is what my 3D printer uses, and most everyone else's 3D printer uses. This is called filament. It's nothing more than plastic in a particular shape, size, diameter. Okay, this particular stuff is 1.75 millimeters in diameter. Now, this stuff is fairly expensive. It's not ridiculous. You can find it for decent prices, but it would be a lot easier if you could just make this stuff. So this video, I'm going to show you what I've done. I'm building my own filament extruder, okay? I'm going to give you all the details you ever wanted, but probably not in this video. This video is going to be an introduction to the filament extruder. Now, for those of you who watched the Smart Scarecrow show of my 3D printing demonstration to kind of just show everybody what's going on with the 3D printing that I've been doing, I mentioned in that presentation that I'm going to be making my own filament extruder. I showed you the auger bit I'm going to use, and I had a few pieces of pipe and a resistor and a temperature controller kind of set up just as a quick, hey, here's what I got. That was last Thursday. Today is the 1st of October. Alright, so on the 19th of last month, I showed basically what I was going to do. So from that day until now, which has been a little over a week, this is what I've constructed. So this is the filament extruder, Russ's filament extruder. This is just a quick look at what I've got going on. So there's the beast. Woo! It may not look like a whole lot, but let me inform you, I did not eat or sleep much in the last week. I got a lot of stuff done on this bad boy. So I'm going to show you what I actually have going on here, but I'm not going to break this down, but I will explain it to you. And I'm going to break this down completely and show you how I constructed it and why I did what I did and how I did it for people that want to replicate such a thing. This has not been tested yet. I don't know if it actually extrudes correctly or if it works right. But this is, like I said, just a quick overview of kind of what I put together in a pretty darn short amount of time. And like I said, I'm going to break this down in another video, but I will kind of give you a quick explanation. So this circuitry right here on my panel, this is forward reverse for the auger, power on and off for the auger. I will have a light here, don't have that yet. And this is a variable speed drive for this motor. I think that's an 8th horsepower motor. You can see it right there. 22 RPM, 8th horsepower. That's a bit overkill, I'm sure, but it's okay. If I really get this stuff running, I could extrude a lot real fast. So forward, reverse, on, off, potentiometer, and the fuse. And again, I'll have the light for that. And here, I've got the thermocouple set up, or the temperature controller, I should say. This is the power light for this system, which I don't know if I'm going to add that yet, but that's where I planned on putting it. Thermal temperature controller and the fuse, and you'll see back here there are two digital relays, solid state relays, and one is for this temperature controller and one is for this temperature controller and this fuse. Now each one of these temperature controllers is going to run a separate piece of my extruder setup here. I'm actually using a 33 ohm resistor as a heating element. It actually works really well, but I'm probably going to have to drill a hole in this resistor and hope that it doesn't ruin it. If it does crack, that's okay, as long as the material stays together. It doesn't really matter. But I think I'll be able to drill a hole in there. I'm going to put my thermocouple as close as I can get it to the tube, because this fits so tightly on here that I can't really get it on there. Then the second heating element, which I got this all pretty tight. Basically, I constructed again out of some resistors. These are 3.3K, so 3,300 ohm resistors, and I've got them in a parallel series configuration. Basically that gives me around 800 ohms, and I'm running 120 volts, so it drops about 60 watts across them things. Now they're only 5 watt power resistors, but I've done some tests and they seem to work. I'm thinking I'm going to have to redo this, but currently it's what I got. And this doesn't really get hot enough fast enough, and I'm pulling or pushing way too many amps into this thing, or I mean watts. Amperage is fairly low. It's like 150 milliamps. It doesn't seem like much, but that's 60 watts across these resistors at 120 volt. That's a little much. So it doesn't heat up quite as fast as I want. I'm probably going to end up disassembling some hair dryers and getting some nickel chromium wire. One thing I forgot to mention is everything that you see here has been recycled from something. The only thing I had to purchase was the actual auger bit, which you see inside there. So that's the quick, very short introduction to this thing. I don't want to take forever explaining all this. I do have two bearings here that hold the auger screw in place, and I have a hex ground that was on the end of this already. Actually, the only thing I did with the bit is whack it off, took the tip off. Other than that, it's all original. I did machine down just a little bit of the auger bit right here because it's trying to rub against my center pipe, which I cut very tight on the inside. Anyway, so there's a hex shaft down here, and I do have right here is a basically I created a live center. I've got a bearing on the inside of here, and then I've got a linear force or compression bearing right there, and then that sits in the center of my shaft, which already had a center point made up in it. The gears and drives and pulleys, all this stuff right here, you see the chain and the sprockets, all came out of a old copy machine. I have actually had this chain and these sprockets probably for about 15 years. It's one of the first big items I ever took apart, a copy machine. Big, giant copy machine. This motor originally had some bad brushes and contacts. I just cleaned everything up and the motor still works. The speed controller, which I'm using here, I can kind of show you underneath here. I've got a big speed controller under here, which I had to make my own heatsink for because the original box that this was in was pretty bad. You can see how the traces actually came off the back of the board there, and I had to resolder all the wiring connectors and stuff back on because it had been in the rain and ruined it, and that's why it was tossed out. You can see how faded these knobs are. They're out in the sun. See how rusty that screw is. Anyway, let's flip it on, and again, this is to run the motor. Alright, this is basically as fast as it will run right here. This is just a take-up. Now I do have some work to do on this, like encase this thing so I don't get my fingers in it, and cover up all the connections and finish the connections here. This is the thermocouple and the wires that go to the front heating element, and the thermocouple and the wires that go to the second heating element. But you can see it turning. Now when I run it, it'll probably run more close to this RPM. But I do have a speed controller right here. This is basically as slow as I can run it with the potentiometer settings on the driver board. That's pretty slow. Barely moving. Again, this is a DC motor, geared reduced DC motor with a DC motor driver. You can see the potentiometers here. I've got oh, I ain't gonna focus. What's it say under there? Current and top speed, minimum speed, and something else. So I can actually fine-tune this thing. Yep, this is the power switch for the thermocouples. And I guess not really the thermocouples, but the temperature controllers. Wow. I wonder what that's touching. That's hot. This is in Fahrenheit, this is in Celsius, but I can switch these around. This one only is in Fahrenheit. This one I can switch between Fahrenheit and Celsius. Yep. So, just for fun, let's see what happens. I tried to make this so I could get a shear action going on inside here. So just for fun, let's stick a piece down in there and see if it'll shear it off. Oh yeah. Very nice. No worries there. Now I won't be sticking filament like this in there. It'll be pellets, but just to show you the tight tolerances I got going on in there. Crunch. I hear it getting to the end. Anyway, better not run too much through there. Oh yeah. Bye bye. See you at the other end. Alright, I'll turn that off before everything gets chewed up. Now, I'm going to have to make a new nozzle. This is actually a fitting. And I welded a fitting right onto a stainless tube. But like I said, not going to go into too much detail right now. I will be 3D printing. I'm drawing it up right now. The hopper from here up is going to go to a 6-inch pipe. And it's going to go down to a 3-inch opening and then fall in here. Now, I've got a few ideas on how I want to make the plastic not stick or get caught in here, or make sure it falls in there. And I don't know if I have to redo my hopper with how I got it set up here, if it's going to get caught or if it's going to suck in. I don't know yet. One thing I could do is add a little bitty air nipple here and pump just a tiny bit of air in there every once in a while, a little burst, and kind of break up anything that's jammed. The other thing is I was going to take a solenoid and just attach, you know, one maybe on one side or one on the both sides or something, and every once in a while just, you know, tap 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 with the solenoid. Set that up on a timer. Anyway, that's basically the entire setup. I just wanted to give you a quick reference of what all I got done in a ridiculously short amount of time, and now it's time to get back to some priority projects and getting ready for the conference. So, yep, just wanted to show you what the filament extruder looks like. And I am so tired. I don't remember eating a whole lot. Yeah, that's all I got for you. I just want to say thanks for all your support, guys, and hopefully you guys learned something from this, and maybe we can use recycled plastic on the side of the street that we find from our TVs and make filament so that we can 3D print with recycled plastic. That would be awesome. Alright, that's it. Let me know what you think. Leave a comment and look for more on this device. I'm going to break this whole thing down. I made it all disassemble in a very unique way so that I can easily clean this thing out and work with different plastics and stuff. So just pay attention to the future. I'd say in a couple weeks you're going to see this thing actually in action. So that's it. Peace and love, you guys. See you later. I'm going to go night-night now. Whee! Sleepy, sleepy, sleepy. Oh, you know what? I gotta go get my lunch bag.
Oh, what kind of lunch bag is it?
My lunch bag for work is in my car here.
Oh, what's in it?
My lunch?
What kind of lunch?
My lunch that I ate.
It's cheese.
Huh?
It's cheese.
Cheese? You're hilarious. I got this.
Oh, that is so pretty, Dad.
Isn't that pretty?
Yeah. How you made that?
One piece at a time.
Oh, that is so gorgeous, Dad.
Well, thank you.
I very like it.
You very like it.
Yeah.
I like it too.
Cheese like that. It's so pretty.
You like it?
Yeah. Are you gonna put that on?
Yeah, I'm gonna put it on you.
Oh,
fits.
I'm gonna put that thing on.
Yeah, it fits just right.
That is so pretty, Dad.
Thanks, Riley.
Man, there's that sticker forward.
Huh?
That thing right there.
I'm gonna plug it in.
Oh. Then it will work. I don't see it like go. It works.
I'll plug it in.
Then what does it do?
What's it do?
Yeah.
It melts plastic.
It smells plastic.
I'm gonna melt some plastic with it.
Today?
No, not today.
The mint plastic. Plastic.
All right.